Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2024, Paper 1, FoundationTier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Work out 280 divided by 7. I'm going to do this as a short division, so I'm going to put a 7 in front of the bus shelter and the numbers 280 underneath. And I'm going to see how many times 7 goes into 2. It doesn't, so I'm going to carry that 2 over to the next column. And then 7's into 28, well that goes exactly 4 times, isn't it? Because 4 7s are 28. So 4 I write up here. Remainder is 0 and 7 goes into 0 times, so my answer is 40. Question 1b, work out 1062 minus 438. I'm going to do this one as a column subtraction, I think, so I'm just going to rewrite it in column form like this, and then let's do the subtraction. 2 subtract 8 I can't do, so I'm going to have to borrow one, aren't I? So make that 5. Make that 12, and then 12 subtract 8, that's going to give me 4. 5 subtract 3 is 2. 0 subtract 4 I can't do. I'm just going to borrow that 1, make it 10. 10 subtract 4 is 6, so the answer is 624. Question 2, part A, complete the statement. 2 meters is equal to something centimeters. Well, I know that 1 meter is 100 centimeters, so 2 meters is going to be 200 centimeters, isn't it? And then part B says complete the statement. 8 kilograms is how many grams? Well, I know that 1 kilogram is 1,000 grams. So 8 kilograms, that's going to be 8,000 grams then, isn't it? And part C says convert 24 kilometers to miles using the fact that 8 kilometers is 5 miles. I think I might just do this as a ratio, you know. So I'm just going to start off with this ratio here that they've given us. So the kilometers to miles is in the ratio of 8 to 5. Okay, now I want 24 kilometers. So if I write 24 under there like that, and then I think, well, how many times does 8 go into 24? Goes in 3 times. So doing the same this side, times it by 3, I'm going to get 15, aren't I? So that means that 24 kilometers is 15 miles. Question 3a, here is a centimeter grid. What percentage of the grid is shaded? Well, let's have a look. We've got 16 squares altogether, and I've got 8 shaded. So as a fraction, that is 8 over 16, which is the same thing as a half, isn't it? And a half as a percentage, as a fraction over 100, is going to be, well, I'd have to times top and bottom by 50. That's going to be 50 100ths, isn't it? So it's 50%. Part B says Kai has shaded 2 small squares on the centimetre grid. He wants 3/4 of the grid to be shaded. How many more small squares must he shade? Well, 3/4 would be, you know, if I divide this up into quarters, like quarters, then 3/4 would be 3 of those big blocks shaded then, wouldn't it? Okay, so I've already shaded 2, so I've got another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more then to shade, isn't it? So how many more do I need to shade? I need to shade 10 more. Question 4a, here is a list of 4 numbers. Use one number from the list to complete each statement. The number closest in value to 7 is. Okay, well, what is the difference between each of these numbers and 7? Okay, well, the difference between 6.92 and 7 is just going to be, well, I'd have to add on another 0.08 onto there, wouldn't I, to make 7. The difference between 7 and 7.27 is going to be 0.27. That's going to have a difference of 0.18, and that's got a difference of 0.14. So look, that's the smallest difference there, isn't it? It's 6.92. And then it says the number that rounds to 7.2 to 1 decimal place. Well, if I'm rounding off to 1 decimal place, I'm rounding off after the first digit after the decimal place. So rounding off after the first digit there, next digit is 2. That one rounds down. That's 6.9. This one rounding here, look, that's going to round up because it's got a 7. 5 or more raise the score. That's 7.3. This one, I'm going to round off there. I'm going to round that one up. That's 7.2. This one I'd round there 4 or less, let it rest. It's going to stay at being 7.1. So the one that gives me 7.2 is that one there, isn't it? So that's my answer. 7.18 rounds to 7.2. Part B says here is a list of 6 numbers. Use 2 numbers from the list to complete each statement. 2 numbers that add to make -1 are. Okay, so we need 2 numbers that are mathematically close together but opposite signs. I think that's going to be -5 and 4, isn't it? So because if I take -5 and add 4 onto it on the number line, it's going to take me up to -1. So that one's -5 and 4. 2 numbers that multiply to give me 20. Well, 5 and 4 do, but one of mine is negative there, so that'll actually give me -20 if I try and do that. Again, -2 and 10 makes -20. But what about -2 and -10? Because a negative and a negative make a positive. So I'm going to say it's -10 and -2. Question 5a. Here are 4 lines on a square grid. Which 2 lines are parallel? Okay. Well, it's definitely not R, is it? Because that one's going in its own direction. It's going to be out of P, Q, and S. Now, if you look at P, that's like 1 along and 2 up. Q is 2 along and 1 up. And S is 2 along and 1 up. So it's going to be Q and S then that are parallel, aren't they? Because they have the same gradient. So Q and S. 5b says here's a different grid. There are 4 points on this grid that each have both coordinates that are whole numbers, and the x coordinate plus the y coordinate is equal to 3. Plot the 4 points on the grid. So the x coordinate and the y coordinate have to add up to give me 3. So I've got 4 x coordinates I could pick from that are whole numbers here, aren't I? So if I've got my x coordinates, they could be 0, they could be 1, they could be 2, or they could be 3. It's the numbers along here. Look, these are the ones I need to pick. Now, if I want the x coordinate plus the y coordinate equals 3, then what I need to do is take 3 and subtract the x coordinate. I'm going to get y then, isn't it? So if x plus y is equal to 3, then y is equal to 3 minus x. So whatever the x value is, if I take it away from 3, I'm going to get the y value. So then when x is 0, y is 3 minus 0, that's 3. When x is 1, then y is 3 minus 1, that's 2. When x is 2, then y is 3 minus 2, which is 1. And when x is 3, y is 3 minus 3, which is 0. So they're my points I need to plot. 0 goes with 3, it's that point there. 1 goes with 2, it's that point there. 2 goes with 1, it's that point there. And 3 goes with 0. So they are my 4 points that the x coordinate and the y coordinate equals 3. Question 6a. Write down the value of 3 squared. Well, 3 squared, when you square something, it means timesing it by itself. So I'm going to do 3 times 3 here, and 3 times 3 is 9, isn't it? Part B says, write down the value of the square root of 144. So we have to work backwards here. Last minute ago we were squaring, now we're square rooting. So I need to think, well, not what number multiplied by itself is going to give me 144. Now, I recommend you remember your square numbers, at least up to 12, in which case you will know that 12 times 12 is 144. If you don't know, it's just a matter of trial and error. You're going to have to kind of work it through and see if you can work out which one it is by picking a number, times it by itself, and see if you get the number that you're looking for. But I recommend you just remember them so you can just list them out, like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So if you can do that, then you'll know, won't you? Okay, so it's just a bit of practice, like, you learn your times table, learn your squares, learn your cubes. Very handy for these sorts of questions. Part C says work out the value of 2 to the power 4. Now 2 to the power 4 is 2 times 2 times 2 times 2. So 2 times 2, that's 4, times 2 is 8, times 2 is 16. So it's going to be 16. Question 7a. At a restaurant, vegan pizzas have 2 different toppings. The toppings are sweet corn, mushrooms, peppers. Complete the table to list all the possible pairs of toppings. Well, they've already got sweet corn and mushroom there, so I guess you can have sweet corn and peppers, or you could have mushrooms and peppers, couldn't you, I guess? Mushrooms and peppers. Part B says, at a restaurant, dough balls can be ordered in small portions and large portions. You can get a small portion of 6 dough balls or a large portion of 10 dough balls. A group of people want to order exactly 44 dough balls. Show how they can do this. Okay, well, I think we need to kind of start with the 6s and keep adding them together until we get a digit of, a unit of 4 on the end, and then we can just add the 10s on afterwards. So if you think about the 6 times table, you get 6, that doesn't end in a 4, 12, which doesn't end in a 4, 18, which doesn't end in a 4, 24 that ends in a 4. So if I do 4 lots of the small portion, that's going to give me 24 dough balls. So then if I then add on, so if I have 4 of those, then I can just add on 2 of those then, can't I? So that's going to give me another 20. So in total, I'm going to get 44. So what do I need? I need 4 small portions and 2 large portions, giving me the 44 dough balls. That's a lot of dough balls. Question 8, we've got apples at 25p each and oranges at 60p each. Sam has £10 to buy apples and oranges. She buys 9 apples and as many oranges as possible. How many oranges does she buy? Okay. Well, let's work out how much her 9 apples cost first. So we want 9 of these and at 25p each. So then we're going to have to work out what 9 times 25 is. I might just write that the other way around. 25 times 9 to start with. So what is 25 times 9? Well, 5 9s are 45, so 5 carry 4. And then 2 9s are 18 plus the 4 is 22. So that's 225 pence, or £2.25 then in pounds. So that's £2.25. And remember, she's got £10 to spend. So next thing, I want to know how much is left after I've spent my money on all those apples. So I'm going to do £10 minus the £2.25. Actually, it's probably easier just to do that in my head. So £10 take away £2 is £8. Take away the 25 pence is £7.75, isn't it? So that's £7.75 left to spend on oranges. And now we kind of need to work out, well, how many times can I buy an orange if it's 60p per orange? Okay, so let's think about multiples of 60. So I guess I want to do £7.75 divided by 60. So 60's into £7.75. Well, I know that 10 60s is going to be £6, isn't it? Okay, so and that leaves me another £1.55. So I think I can buy another 2 which would be £1.20. So that takes me up to £7.20. Now I can't afford another one, can I? Because that would take me up to £7.80. So altogether, then I'm going to be able to buy 12 oranges. Okay. Now I could have done a formal division here, but sometimes it's easier to kind of use less formal methods on these sorts of questions. So if it's easier to kind of just chunk it and work up like that, then that's what we do. So 12 oranges is what she can buy. Question 9. Alina and Sue play netball. The number of goals they scored in 8 games is shown. Okay, so you can see how many Alina scored and how many Sue scored. I guess each one of these columns is one game. So in this particular game, Alina scored 12 and Sue scored 13. I've got a table here that I need to complete. The first column says range. I already know Sue's range is 18, and I want to find Alina's range. Now remember, range is highest minus lowest, isn't it? Range equals highest minus lowest. Now you can see from Sue's, her highest was 31 and her lowest was 13, and that's where the range of 18 comes from then, isn't it? Because 31 take away 13 is 18. So doing the same thing with Alina, her highest score was 26 and her lowest score, well, was that 12 down there, isn't it? So, and 26 minus 12, that is 14. So her range was 14. Median is the middle one as you have them arranged from the smallest to biggest. Now actually, spookily, these are already arranged from the smallest to biggest, aren't they? Okay, so I don't need to sort them out. I just need to work out where the middle one is. Now I've got 8 games, so which one is the middle one? If you know the number of games you've got, if you add 1 and divide by 2, that's going to tell you where the middle one is. So 8 plus 1 is 9, divided by 2 is 4.5. So it's the 4.5 value that we need to find. In other words, it's kind of halfway between the 4th and the 5th value. So if we find the 4th and the 5th value, which is those two there, we want to find the kind of halfway point between those two. So halfway between 20 and 22 is going to be 21. Okay. Part B says, which player scored the more consistent number of goals? Consistency is to do with dispersion, the measure of dispersion. The measure of dispersion we've got here is range. Median is a measure of average or central tendency. So we don't want the median, we want the range in this case. And because Alina's range was smallest, we can say that Alina was more consistent. So I'm going to tick that Alina was more consistent, and I'm going to say her range was 14, which was smaller than Sue's, which in brackets I'm going to write 18. Okay. Question 10, work out 35% of 1,200. Now this is the non-calculated paper, so I'm going to be using a non-calculated method for working out this percentage. I'm going to chunk it, so I'm going to start with 100%, which is 1,200, and I'm going to work out what 10% and 5% is and add them up. So 10%, what's 10%? Well, 10% is a tenth of 100%, so a tenth of 1,200 is going to be 120. Now I need 3 of those, don't I? I need 10, 10 and 10 to make 35%, plus I need a 5%, so I need a 120, a 120, a 120. And what's 5%? 5% is half of 10%, and half of 120 is 60. So now I've kind of got all of those. I just need to add up the bits I need. So I need a 10, a 10, a 10, and a 5. That makes 35, doesn't it? 10, 10, 10, and 5 makes 35. So adding up my other side, I've got 0, 0, 0, 0. So that's 0. I've got 2, 4, 6, and 6 makes 12. 2 carry 1. And I've got 1 carried plus 1, 1, 1, which is 4 altogether. So that's 420. Question 11. A window cleaner uses this formula. C equals 2W plus 5, where C is the cost in pounds for the customer, and W is the number of windows to be cleaned. Okay, so basically it's £2 per window plus a flat fee of £5 added on top. So how much does it cost for 6 windows to be cleaned? Well, for 6 windows, W is equal to 6 then, isn't it? So subbing that into the formula, C is equal to 2 lots of W, 2 lots of 6, plus 5. 2 lots of 6 is 12, and 12 plus 5 is 17. So it's going to charge £17 for that. Well, he's a lot more expensive than my window cleaner. Right, B, the cost for another customer was £24. Show why this cost must be incorrect. Okay, so we're saying that the formula C is equal to 2W plus 5, isn't it? So if the cost was 24, what does that make W, the number of windows? So 24 equals 2W plus 5. Taking 5 away from both sides, that's going to be, they're going to cancel, aren't they? Leaving me with 2W on the right, like that. And on the left, 24 take away 5 is 19. Then to find the number of windows, then I'm going to have to divide both sides by 2. What do you notice? W then is going to be half of 19. What's half of 19? 9.5. So that means this person had 9.5 windows. So number of windows should be a whole number. Okay, so it should be a whole number and not 9.5. Okay, so that's how I can tell they're wrong. Question 12. 2 bags X and Y each contain some coloured discs. In bag X, 7/20ths of the discs are red. In bag Y, 2/5 of the discs are red. Which bag has the greater proportion of red discs, X or Y? Now, basically, all we need to do here is work out which is the bigger fraction out of those two amounts. Now, the problem is, at the moment, we've got different denominators. I've got a 20 up here and a 5 here, so that makes it difficult to compare. But I can pretty easily change 2/5 into 20ths. So 2/5 is the same thing as what in 20ths? Well, 5 goes into 24 times, so timesing that by 4 as well. I know that that is 8/20ths. So that means 8/20ths is bigger than 7/20ths. Okay, which means there is a greater proportion in bag Y. Okay, because 8/20ths is bigger than 7/20ths. Question 13a. 2 friends share £240 in the ratio of 1 to 3. Work out the largest share. Okay, well, how many shares have we got altogether? One friend gets 1 share and the other friend gets 3 shares. So altogether, that's 1 plus 3 equals 4 shares, isn't it? 1 plus 3 equals 4. So if there's 4 shares, what's the value of each share? Well, if I take £240 and I divide it by 4, what's that going to be equal to? 4s into 240. 4s into 2 don't go. 4s into 24, that goes 6 times, isn't it? Remainder nothing, it's 60 times. So 240 divided by 4 is 60. So that means each share is worth £60. So the ratio of 1 to 3, if I times that up by a factor of 60, I should know what each one gets then. So 1 times 60, that's just 60. And then 360 is 180. So that means the largest share is that one then, isn't it? The largest share is this one. So the largest share is £180. Part B says a tennis player wins or loses matches in the ratio of win to lose 5 to 9. What fraction of the matches do they win? Okay, so if they win 5 games for every 9 games they lose, then altogether that's 5 plus 9. That's 5 plus 9 is 14 games then. So in 14 games, they win 5 and they lose 9. So what fraction do they win? Well, they win 5 games in every 14 games then. Okay, so the 5 plus the 9 makes 14, which is the denominator of our new fraction. So it's going to be 5/14. Question 14. Here is a multiplication table. Some big numbers appearing here. Use the table to answer the following questions. 38,043 divided by 63. Okay. So we're dividing here, not times in, and we're dividing a big number. But if you look on the table here, look, 3843, where does that appear? It's here, isn't it? So I know from the table that 3,843 is 63 times by 61. Okay, so then if I'm dividing by 63, that big number, I'm going to be left with the other one, aren't I? I'm going to be left with the 61. Because if 63 times 61 is 3843, then 3843 divided by 63 is going to give me back the 61. So that one there is going to be 61. Part B says work out 6.1 times 6.7. Now I don't have 6.1 and 6.7 on here, but I do have 61 and 67, and that gives me 4087. So I'm going to get the same digits in my answer. I'm still going to get the digits 4087 in my answer. But remember, I've got 2 digits appearing after the decimal point in my question. So I'm going to get 2 digits appearing after my decimal point in my answer. So it's actually going to be 40.87 for that one. Question 15. These two triangles are congruent. Now, congruent in maths is a very particular word. It means they're exactly the same shape and exactly the same size. So that means all the angles are the same and all the sides are the same. Write down the value of x. Well, if these are two congruent triangles, then we can just pair them up, can't we? So the 5 here matches with the 5 here. The 8 here matches with the 8 here. So if they're congruent, then this 6 here should match with that x there then, shouldn't it? And that means that x has to be 6 centimeters. Question 16. C and D are positive numbers. C is even, D is odd. Tick a box for each expression. Right. C plus D, an even plus an odd. Well, let's think this through. Let's say C was 2 and D was 3. Then C plus D would be 5 then. Is that even or is that odd? It's odd, isn't it? But is it always odd? What about if we picked a different even number and a different odd number? Does that make any difference? Well, 4 plus 7 is still odd, isn't it? So whenever you've got an odd number and you add on an even number, you're going to go back to an odd number, aren't you? Because you're going to an odd number every 2 numbers. So yeah, I think it's always going to be odd, that one, isn't it? Okay. What about 4C? 4C. Well, if C is even, and let's say it was 2, then 4C would be 4 lots of 2, which would be 8. That's also even. Now, is that always true? If C was 4, 4 times 4 would be 16. That's also even. If C was 6, 4 times 6 is 24, is also even. And even times an even is always even, isn't it, if you think about it? So that one is always even. Now, what about C divided by 2? C divided by 2. What's that going to be? Well, let's try a few different numbers. Well, you know, we said if C was 2, what would C divided by 2 be? C divided by 2 would be 2 divided by 2, which is 1. So if C was 2, then I get 1, which is odd. What about if C was 4? That would be 4 divided by 2, which is 2. Okay, so it could be either odd or even in this case. So 2, when you divide it, you get 1. 4, when you divide it, you get 2, which is even. 6, when you divide it, you get 3, which is odd. 8, when you divide it, you get 4, which is even. So I think for this one, you can't tell because it could be either one depending on the value of C. Question 7. A linear sequence has first term 10, first term plus second term is 39. Work out the fifth term. Okay, so we got a sequence, got 5 numbers that we're interested in. Okay, I know that the first term is 10, so that's going to go here, isn't it? So the first term is 10. Second term, first term plus second term is 39. So if I know that the first term is 10, then the second term is going to be 39 minus 10 then, that's 29. Okay, so 29 must go here. Okay, so that comes from here, which came from here really. So that's 29. So, and we know it's a linear sequence, and a linear sequence means it's going up by the same number each time. Now this one is going up in 19s, isn't it? I've added 19 there. So if it's going to continue being a linear sequence, I'm going to keep on adding 19. I'm going to add 19. I'm going to add 19. I'm going to add 19. Okay, so I just need to count up in 19s from 29 then. So 29 plus 19, what's that? 39, 48. Plus another 19 is what? 48, 58, 67. And 67 add 19, 67, 77, 86, isn't it? So then that's going to be my last term of this that I'm interested in, the fifth term. So my fifth term is going to be 86. U5, fifth term, is 86. Question 18, work out the area of this triangle. Oh, that's quite straightforward because I've got a formula for that. Area of triangle is just equal to a half times base times height. Now the base of this triangle is just this line here. That's the base, so that's 20. So a half times 20 times the height. Now the height is the perpendicular height, and the perpendicular height is this one here. Look, that's 6.3. So I just need to work out what's half of 20 times 6.3. Okay. Now, you can actually half any of the numbers. It makes sense here to half the 20. So if I half the 20, I'm going to get 10. That's going to make my multiplying a lot easier then, isn't it? And I just have to do 10 times 6.3. And 10 times 6.3 is 63. So my answer is 63 centimeters squared. The vector -3, 7 translates A to B. Write down the vector that translates B back to A again. Okay. Column vectors usually have the form x over y like that. So this value here means -3 units in the direction of x, and this value here means 7 units in the direction of y. So let's say I make a note of the point A, it's here. To get from A to B, I would be going 3 units in the opposite direction of x, so like 1, 2, 3 in that direction, and then 7 units up. 1, 2, 3, 4, 5, 6, 7. So that would be my point up there, B. Okay, so I'd be going 3 to the left and I'd be going 7 up. And then that is my vector. Let me just draw that on. Now, if I want to go from B to A, I'm going to go along that vector in the opposite direction. So rather than going 3 to the left, I need to go 3 to the right, don't I? And rather than going 7 up, I need to go 7 down. So my answer would be 3 to the right and -7 up. Okay, so that's going to be my opposite vector. I'm going in the opposite direction. So basically I'm just flipping the signs around, aren't I? If you want to go down the vector in the opposite direction, change the signs. The attendance for a rugby match is 8,400 people to the nearest 100. Write down the minimum possible attendance. Okay, so if it's been rounded off to the nearest 100, if we imagine a number line with 8,400 marked on it and going up in hundreds, then the next number on that scale would be 8,500, and the one below it would be 8,300. Okay, so if we were rounding to 8,400 to the nearest 100, we would be rounding from halfway between or closer. So it's this range of values, isn't it? So if you're halfway between those numbers or closer to 8,400, you're going to round to 8,400. Okay, so what are the limits? What is halfway between? So the lower limit is going to be 8,350 and the upper limit is 8,450. So what is the minimum possible value? The minimum possible attendance is going to be that one, isn't it? The lower bound. Okay, so it's going to be 8,350. And then part B says write down the maximum possible attendance. Well, the maximum possible attendance is the upper bound then, isn't it? It's going to be that one there. So it's going to be 8,450. Well, except 8,450 would actually round up. And because this is made, people are made out of discrete things, aren't they? So, you know, you have one person, two people. You don't have 1.175 of a person. So in this case, if it is discrete data, you usually expect to come one down from the upper bound because technically 8,450 rounds up. Now, if it was a continuous number, I would just leave it as 8450, but it isn't. It's discrete, so that's the reason why I'm actually going to come down one to 8449. Question 6. The table shows the number of workers at a company in different years. We've got 2015 through to 2022 here then. And I've got a time series graph is drawn to represent the data. The first 4 points have been plotted. Complete the graph. Okay, so we've plotted 29, 34, 42, and 52. So we've already plotted these 4. And we now need to plot the rest. We need to plot these other 4 here. There. So we're going to start at 2019 at 62. So 2019 at 62. Now there are 5 little squares between 60 and 70. So each little square is going to be 10 divided by 5 or 2 units. So 62 is 1 little square above 60. And then 2020 goes with 70. That should be a nice easy one to plot. It's just on both big lines. 21 is at 76. So 76 is going to be 3 little squares above 70, isn't it? Okay, 2, 4, 6. Yeah. And then finally 80. That should be another easy one to plot. Okay. Now for a time series, we just join up the lines with a straight line. Okay, individual lines. So a straight line from that point to that point, a straight line from that point to that point, and a straight line from that point to that point. Part B says estimate the number of workers in the company in 2023. Okay, now in order to do that, I'm going to draw on a trend line going up through my data. Okay, so now you can see that the points aren't exactly straight. But it's a bit like a line of best fit, you know, you have to kind of angle your line around as best you can to kind of show like a trend line. So I think it's going to probably continue in that sort of direction like that. Okay, so finding the general trend and then just extending my line then on a little bit. Okay, and then I can read off that point there where it crosses 2023. So where's 2023 going to be? 2023 is going to be on this one here, isn't it? So it's that point there that we need. So what's that? Right, so that comes out to be 80, what, 4 little squares up from 80. So it's going to be 88, isn't it, on that line there? So we're going to go for 88. And here is a cone. And we know that a curved surface area of a cone is pi r L, where r is the radius and L is the slant height. And Beth tries to work out the curved surface area in terms of pi, and she's written down pi times 5 times 12, which is 60 pi centimeters squared. What mistake has she made? Well, the curved surface area of the cone is pi r L, where r is the radius, in this case it's that distance there, and L is the slant height, it says here. Now that slant height is this one. Okay, that's the slant height. This one, the 12, that's what we call the perpendicular height. Okay, so that's the perpendicular height. The green one is the slant height. So she has used the perpendicular height when she's meant to use the slant height. So I would say that she should have used 13 and not 12. So I've written she should have used the slant height 13 and not the perpendicular height 12. Part B says Adam uses pi equals 3 to estimate the area of the base of the cone. Work out his estimate. Okay, so the base of the cone is just a circle. So area of the base is going to be pi r squared. Now we know that the radius is 5. So that's going to be 5 squared. And we're estimating pi to be 3. Now, it's not a great estimate of pi, but that's what he's gone for. So that is 25 times 3, or 75 then is the answer, isn't it? 75. Beth uses 3.14. That's a better estimate for the area of the base of the cone. Is Beth's estimate more or less than Adam's estimate? Tick a box. Well, she's used a bigger version of pi, so yeah, your answer is going to be bigger. If you're times and through by 3.14 rather than 3, you're going to get 0.14, lots of 25 extra on your answer, so it's going to be more. I would say that 3.14 times 25 is greater than 3 times 25. Question 23. Each day, Eric drinks a quarter of a pint of milk in the morning and half a pint of milk in the afternoon. How many pints of milk does he drink in 30 days? Well, how much does he drink in one day? So at the moment, he's drinking a quarter and then a half, isn't he? So what's a quarter plus a half? So every day, each day, it's going to be 1/4 plus 1/2. Add in fractions with different denominators. Just want to change this one, isn't it? If I change the 2 here to make it a 4, just by multiplying top and bottom by 2, I'm going to get 1/4 plus 2/4 plus 2/4, which is 3/4. So he's drinking 3/4 of a pint of milk a day, and we want to work out how many pints of milk does he drink in 30 days. Well, it's going to be 3/4 of 30 then, isn't it? So what is in 30 days? It's going to be 3/4 of 30. Now, unfortunately, 4 doesn't go neatly into 30. But what I can do is I can just turn it into a fraction then. So I can do 3/4 times 30 once. So what's that then? So 3 times 30 is 90, and 4 times 1 is 4. So I've got 4 94ths. So what's that then? How many times does 4 go into 90? 4 goes into, I might just do it at the side up here. So 4's into 90. 4's into 9 go twice. Remainder 1, isn't it? Because 4 2's are 8. And then 4's into 10 go twice. Remainder 2. Now I haven't got anything to attach the 2 to, so I'm just going to put an extra 0 in like that, and then attach the 2 to that, the remainder. And then I can do 4's into 20, and that goes exactly 5 times. So that's 22.5 or 22.5 then, isn't it? So that is 22.5 pints. Question 8. Solve 7x minus 22 equals 4x plus 29. Okay, so we've got a linear equation here, unknowns on both sides. So let's try and resolve that. I've got 7x and 4x here and here. So if I take the smaller one away from both sides, so take off 4x from both sides, then they'll cancel on that side. And it will leave me with 7x take away 4x, which is 3x. So I get 3x minus 22 is equal to 29. Next step, let's get rid of that 22 on the left-hand side by adding 22 to both sides. Again, that will cancel. And then that will leave me with 3x equals 29 plus 22. That's 51, isn't it? So 3x is 51. And then finally, divide both sides by 3. We'll cancel those. Leave me with x. And then 51 divided by 3, that's 17 then, isn't it? So x is 17. And in a house, the floor area of the living room is 26 square meters, and the floor area of the kitchen is 16.4 square meters. Express the area of the living room as a fraction of the area of the kitchen. Give your answer is as a fraction in its simplest form. So we've got, I want to write this one as a fraction of this one. So if I'm writing one number as a fraction of the other, the number itself is the number at the top, it's the numerator, and what it's a fraction of is the number at the bottom. So I've got 26 over 16.4 here. Okay, so we can't really have fractions with decimal numbers in, can we? So how can we get rid of that decimal? Well, probably the easiest thing is just to multiply top and bottom by 10 to start with. Just get rid of the decimal and then look to cancel after that. So I've got 260 over 164. And now I want to see if I can cancel that down. So common factors of 260 and 164. Well, I think it must, 4 must go into both of them, mustn't it? So dividing them both by 4, perhaps to start with. What's that? 4's into 260. Well, 4's into 26 go 6 times remainder 2. So that'd be like 6 and then 4's into 20 go 5. So that'd be like 65 over, and then 4's into 164. Well, 4's into 16 go 4 times, and 4's into 4 go once. So that's 65 over 41. Just dividing top and bottom by 4. Have we got any more common factors? 65 and 41. They don't divide by 3, do they? Not 5 either, not 7, not 9, not 11, not 13. So I don't think we're going to get these any more simple than they already are. I think it is going to be 65 over 41. Okay, so that's about as far as I can get. Represent -2 is less than x, which is less than 4 on the number line. Okay, now we can do this by drawing two circles at -2 and 4. I'm going to draw a circle here, and I'm going to draw a circle up here. Now these need to be open circles because the value themselves is not part of the range of possible answers. Okay, and then we're going to join them up with a straight line. So x can be any number between those 2 points, but it can't actually be the endpoints. That's why we don't fill them in. And then it says solve 5x plus 14 is greater than or equal to 11. Now these solve very similar to linear equations, inequalities, so I'm going to do it the same thing. I'm going to take 14 away from both sides, kind of simplify the left hand side, so they'll cancel, leaving me with 5y on the left. 5y is greater than or equal to 11. Take away 14, that's -3. And then dividing both sides by 5, then I'm going to get y is greater than or equal to -3/5. Now, there's no reason for you to convert that into a decimal. You're not a computer. Fractions are your friends. Just leave it like that. Move on. Y is greater than or equal to -3/5. Question 11. Describe fully the single transformation that maps shape A to shape B. Okay. Now this is an enlargement. I can see that already because the shapes are saying change size. But notice the original, the object, is bigger than the image. So this enlargement has actually made my shape smaller. Now that's fine. That can happen. It happens when you're using a fractional scale factor, so that's something to bear in mind. Now what I'm doing is I'm joining matching points together on object and image. Now the reason I'm doing that is because there's always a straight line from center of enlargement through the object out to its image. So if you do this a few times, you should find that all your lines end up converging on one point, and that one point will be the center of enlargement. So by joining up these matching points on object and image, I will be finding the center of enlargement. Okay, so a slight problem with my pen lining up there, but hopefully you can see that the center of enlargement is this point here, isn't it? So this is my center of enlargement. Now, to describe a transformation of this type, an enlargement, I need to know three things. It tells you here number of marks, how many things you need to say in order to get it. Right, so to get all those 3 marks, the first thing I need to say is the type of transformation it is. It's an enlargement, so that is worth 1 mark by itself. And then the next thing would be to mention where the center is. So where is the center? The center is that point down there. It's 1 minus 7, isn't it? So it's centered at 1 minus 7. And then the last thing I need to mention is the scale factor. Now you'll notice that A is twice as big as B along each of its dimensions. Look, that side there is twice as big as that one. But remember, we're starting at A and we're going to B. So really, B is half the size of A rather than A being twice the size of B. So the scale factor here then is a scale factor of 1/2. So yeah, 1 mark for enlargement, 1 mark for the center, 1 mark for the scale factor. Okay, 3 marks achieved.
Mr. T, he's the best, helps you ace every test. Maths maths worries now.